So now if you know the quotient rule, it becomes easier to find the derivative of some of the common trig functions we work with. So starting with tangent x, it's helpful to know that tangent x is just equal to sine over cosine, sine x divided by cosine x. So now we have a quotient rule. So we'll start by doing the derivative of the numerator multiplied by the denominator, low d high. So we get the derivative of the numerator is cosine x, and we're going to multiply that by cosine x, the denominator, less. Now we're going to do high d low, so we leave the numerator, and multiply that by the derivative of the denominator, which is negative sine. So since it's negative sine, instead of writing negative sine, I'm just going to switch this negative to a positive, and then just write sine. Okay, and then square the low, we get cosine squared. So then carrying on, cosine times cosine is cosine squared. Sine times sine is sine squared. And then still dividing by cosine squared. We won't go into proving this or why this works, but in pre-calc or whenever you do trig in the curriculum, we go through the Pythagorean trig identities, and one of them, very useful, is cosine squared plus sine squared is actually just equal to 1. So we get 1 divided by cosine squared of x. And then, since cosine is just the reciprocal of, since secant is the reciprocal of cosine, we can say 1 over cosine squared is just equal to secant squared. So then, most simplified form, final answer, the derivative of tangent x is just secant squared x. And then you can do something similar with cotangent x. You should get negative cosecant squared if you do your quotient rule correctly. So now moving on to the derivative of secant, we've rewritten this as 1 over cosine, again, because the reciprocal of secant is cosine, and the reciprocal of cosine is secant. So now we have a quotient rule, and our numerator is a constant, which makes this slightly easier. So if we do the derivative of the numerator multiplied by the denominator, well, low d high, well, that's just 0 times cosine, which we know is just going to be 0. So that whole part's going to go away. Less. Okay, numerator multiplied by the derivative of the denominator, which is negative sine. So again, instead of writing negative sine, I'm just going to put a plus sign right there, and then we'll say sine. Okay, then square the low, we get cosine squared. Alright, so let's simplify. We just get sine on top, and then I'm going to do this thing where instead of writing cosine squared, I'm going to write cosine times cosine. Because now what we see is we have sine over cosine, and then another cosine in the denominator. So how we can write this is we can rewrite sine over cosine as tangent. Okay, so this is technically tangent divided by cosine, but again, we know that 1 over cosine, so we just have this like cosine in the denominator here, can be rewritten as secant. So we usually put it in this order, because then we can say, oh, the derivative of secant is just sextanks, okay? And we've just shown that by using our quotient rule. Go back through that, make sure we're comfortable with everything, and yeah, it looks pretty good. So yeah, we write the derivative of secant x is equal to the derivative of 1 over cosine x, which is just equal to secant x tangent x. Secant x times tangent x, ran out of space there. Okay, that's it. So you should try to find the derivative of cosecant x in a similar way. You should get negative cosecant cotangent.